save some time. So on the left, you'll see that there's the vertical format. On the right, you'll see the horizontal format. Vertical, again, basically we stack up the like terms. It's just going to look like you're adding multiple digit numbers. Make sure that you're following the rules of exponents when you're combining those like terms. You just add them and keep them the same. So 3x cubed plus x cubed is going to give me 4x cubed. 2x squared minus 10x squared is negative 8x squared. Notice I left kind of a blank space here because the other term, the second term in this problem, didn't have an x to the first power, so I just left it blank so I didn't accidentally combine stuff. And then negative 7 plus 8 is positive 1. Excuse my son in the background. He's going to be making some noise, I'm sure. So in the next one, again, horizontal format, we basically take things, and if there's a like term from the next expression, we're going to put the like term next to it. 9y cubed did not have a like term, so we're just going to copy down 9y cubed. 3y minus 5y squared is negative 2y squared. Negative 2 plus 1 is negative y. 1 minus 4 is negative 3. So we're just combining like terms here, you guys. It should be pretty quick and simple. Subtracting vertically and horizontally is the same thing. I'll show you something when I am writing down horizontal. Vertical, I'm going to write it out really quick and discuss that as I go through too. Okay, so typically if someone does subtracting polynomials, what they do is they stack them up vertically. Now, keep in mind here, this negative sign is going to change the signs. So what I more often have students do when they're subtracting polynomial expressions is that they leave the first expression exactly the same. So I'm going to copy this down really quick. And then the second expression, instead of writing minus and worrying about double negatives, what they do is they actually distribute that negative through. So it's going to say negative 2x to the third minus 6x squared plus x minus 1. Now that we've done that, this minus, because I've distributed it through, can turn back into my plus, and I can do it exactly like addition of polynomial expressions, and you end up getting the same answer either way. So 8 minus 2, if I'm doing the left way, 8 minus 2 is 6x to the third. Negative 3 minus 6 is negative 9x squared. Negative 2 minus negative 1 is negative x. 9 minus 1 is positive 8. If I do the right side where I'm adding, again, I get the same thing, but I don't have to worry about sign errors. So they're both negative. I add them up and keep the sign. Negative 2 plus 1 is negative 1. 9 minus 1 is positive 8. So you can see here that I get the same answer for both expressions. Horizontally is a little bit different. Again, keep in mind the vocabulary here. You're subtracting the first one from the second one. But I have 2z squared, and I'm going to subtract subtract positive 3z squared from the second equation from that. So again, I don't want to put minus a positive, I'm just going to put minus. Then in my in the expression I'm subtracting from, I have positive 3z, and the like term that I'm subtracting from it is negative z. And then I don't have a first power term, but I'm subtracting essentially negative 4. So again, that's gonna have some issues there. When I do that, it's gonna turn that 4 positive. When I go to combine like terms here, it should be pretty straightforward. 2 minus 3 is negative 1z squared. 3 minus 1 is positive 2z. And then double negative 4 is going to be plus 4. So there's my answer to example 2, part B. You guys can see there, though, that if you want to stack them up vertically and distribute a negative, it's exactly like the first problem. So again, take a couple seconds here, try these. Ollie, stop trying to cough into it. Take a couple seconds and try these out. Once you hit play again, these will be written out and solved for you, and you can look them over. So again, I just stacked them up vertically. When I do them, you guys, I'll typically do them vertically. When we take tests and assessments and stuff, you guys can pick either way is more, I don't know, easy for you to see, I guess. but I'm going to typically do them vertically. So 2 plus 7 gives me 9, negative 6 minus 1 is negative 7, 5 minus 9 is 4. So there's my first expression. The second one, I distribute that negative through just so we don't have those double negatives issues. 3 minus 5 is negative 2, 8 plus 1 is 9. I didn't have an expression for the t in the in the second one, so I left it blank. So negative t minus nothing is negative t. Negative 4 and negative 17 is negative 21. Be sure that you guys come and ask if you have any questions on that. So again, multiplying vertically and horizontally, you guys, this is going to be completely up to you. Whatever is actually easier for you would be fine with me. I'm going to write them out first, and then as I get them written out, I'll go ahead and play the video and show you how to work them out. Okay, so the vertical method, you're basically going to treat it like you would whenever you're multiplying like multiple digit numbers together and you stack them up. So negative 3 and negative 4 gives me negative 12. Whatever the sign of the product is going to dictate the sign that goes in front of the number. Negative 3 and 2x gives me negative 6x. Negative 3 and negative x squared gives me positive 3x squared. Again, much like in a 3 times 2 digit number, we're going to need to leave a blank spot here. And if you do that correctly, you'll notice x times 4 is going to give me positive 4x. The like terms will stack up. X times 2x is going to give me 2x squared. And x times negative x squared is negative x cubed. Now that I have those written out, I can go ahead and combine my like terms. So I have negative x cubed plus 5x squared minus 2x minus 12. The horizontal method's actually pretty easy as well. Basically what you do is you take, instead of a single term, I'm going to take this thing times this binomial times the first term, second term, and third term. So when I write that out, it looks kind of like this. It's going to get a little lengthy here, so I might need to slide over as I write it. But I have 3y squared times y plus 5. And then I have minus 2y times y plus 5. And then I have plus 2 times y plus 5. Now as I do this, I'm just going to distribute and then combine like terms when I'm done. So I have 3y to the third plus 15y squared minus 2y squared minus 10y plus 2y plus 10. Then I just combine my like terms. So I have 3y squared plus 13, that was cubed, plus 13y squared minus 8y plus 10. And there you have it. There is multiplying polynomials. Again, we've essentially done this before in Algebra 1 with binomials and trinomials. We've seen this before. This is just kind of a recap into what we've done so that we can see this next stuff easier. Again, this is just more of the same. I think this in your textbook is more you understanding what you are and you are not allowed to do. But what we need to understand here is if I'm multiplying 3 binomials together, I need to know that I can't just distribute the first term through both and then the second term through both and expect to get the right answer. What we need to do is we need to pick 2 to combine. I'm just going to pick the right 2, and then once that's done, distribute that x minus 1 through. So x minus 1 is going to get left alone, and then I'm going to actually distribute FOIL the second 2, so x squared, and when I combine those, it'll be plus 9x, and then plus 20, and you guys can check that if you want. Then I'm going to take the x minus 1 through, so if I do that, I'm going to go over here and do it actually vertically. So x squared plus 9x plus 20, and I'm going to stack these up, x minus 1, and negative 1 times 20 is negative 20, negative 1 times 9x is negative 9x, and negative x squared. I'm going to leave my space. I have x times 20 is positive 20x. I have x times 9x is positive 9x squared. And I have x times x squared is x to the third power. When I combine those like terms, I get x to the third power plus 8x squared plus 11x minus 20. And there you have it, multiplying three binomials. Okay, so this is actually something that students have seen before. We've learned how to factor these in Algebra 1, at least the top two. You've seen the sum and difference product patterns, and if you FOIL this out, you guys will see that this pattern will always hold true. And then you have the square of a binomial pattern. And again, we've factored this before, we've used it a ton, and I always have students tend to just overthink this process. All you need to understand is that the first term is your A, the second term is your B, and whatever this sign is in the middle dictates whether you put the plus here or the minus here. The second term is always going to be b squared. For cubic roots, it's going to be a little bit different, but for the most part, it's the same. You're following this pattern, you're plugging in values for a and b, and you're solving, basically. Now, if there's just numbers in both, it's pretty easy. And if it's variable expressions, again, you just have to know what variable expressions you are allowed to combine. So what I'll end up doing here is plugging it into the equation and talking through it as I go through the next couple.